In my previous videos, I have discussed about the forward propagation, backward propagation. In these videos, I'm going to discuss about the activation functions. So, what is an activation function, or what are activation functions? So, function is basically a mathematical operations which decides whether a neuron should be fired or not, whether a neuron should be activated or not. After the summation, we apply the activation function. So the summation can be a very large number or very small number. Whether it should be activated or not, it's decided by the activation function. Okay. So and then why do we need activation function? Okay. So basically, as I said just now, neural network computes the weighted sum of the input and the bias. This sum of the inputs and the bias can range from minus infinity to plus infinity. So we need to decide which value, above certain value it should be activated, or below certain value it should be deactivated. We should decide. So since it ranges from minus infinity to infinity, it becomes very troublesome to decide what should be the threshold. So the activation function bound the values of the neural output. So it will bound like from here to here. It should be uh, it should activate from here to here. It should deactivate. And another important function is it induces non-linearity in the network, allowing it to be more complex, allowing it to learn more complex tasks. Non-linearity means like not a straight line, whereas if not, if we don't use activation function, it will be a linear function which can which will either increase or decrease based on the input value. If the input value increases, the output increases. If the input value decreases, the output decreases. Okay, so it's going to be something like this. Let me show. So it's linear is basically is a straight line. They can pass here, or it can be this straight line, or it can be this straight line. So it's linear. With activation function, we induces non-linearity in the data. So it's not going to be like this. It's basically could be some like this, could be like this, or could be like this. Okay. So this we will discuss in the types of activation function. So how many types are there? There are it can be categorized into three types. First is the binary step function, which has only zeros and one, either true or false. Oh, then we have the linear activation function. So as I discussed, linear means it's a straight line activation function which produces only a linear or straight line features. And the next we have non-linear activation function. This is the activation function which is going to be mainly used in most of the neural networks. Okay, in non-linear activation function, I have bring up some of the mostly common use activation functions. So first is a sigmoid activation function. Okay, next is the 10H. This sigmoid and 10H are pretty similar. Then we have ReLU, rectify linear units, and then we have leaky ReLU. Then the next is parametric ReLU. Then we have ELU exponential linear unit, then SELU scale exponential linear unit, then we have Gaussian error linear unit, then next we have softmax, and the last but not the least we have Swiss. Of all these six are a variants of ReLU. Okay, so next go and check what is binary step function. So the binary step function, what is it? Is there is a threshold which determines whether the neuron should be activated or not. It has only two states, whether the neuron is high, is say 1, or low, which is can be 0. If it's greater than certain threshold, it can be activated. If it is below certain threshold, it is deactivated. So it's called it binary step function. So this is a sample diagram. So here these are the 0 state deactivated, and this is the active state, which is say which is above this threshold, we set it to active. Okay, in the function, how do in mathematical notation it can be written like this: 0 if it is x is less than 0, 1 if it x is greater than 0, or instead of 0 you can use this threshold 7.5, something like that. Okay, so what are the limitations of binary step function? It can use in just binary class. Okay, it cannot be used in multi-class classification. Okay, if there are 4 classes, how do we represent it? Is not representable, so we cannot use in multi-class classification. Then what is the other ones? Since these values are constant, okay, in the backward propagation we need to do the derivative of this. If you do the derivative of 0 or derivative 1, it's always going to be 0. So when the derivative is 0, you cannot do the backward propagation. Okay, everything is basically going to be 0. Okay, so this is a limitation of binary step function. The next we have linear activation function. So what is linear activation function? Yes, it's also known as straight line function or identity activation function, and it's proportional to the input. It's like increases the value in the input, the output will increase. If you decrease, the output will decrease. So this is the graph, a straight line. It is always linear, is always a straight line, and the function, mathematical function is fx equal to ax plus b, where b is the y-intercept here, that is y-intercept here, this value, this length, and a is the slope of the line, the slope of this line. Okay, so what are the limitations of linear activation function? Similarly, like the binary step function, when you do the differentiation of this function, if you do the differentiation of this function with respect to x, you will get a, which is a constant. So hence it is not related to the input, hence we cannot do any, not possible to do a backward propagation, so it cannot be used in the backward propagation. Okay, then the next thing is like irrespective of how many layers you use, like 5, 10, 15, 20, the output, the final output is always going to be a linear function, finite with respect to the input. So it's meaningless. Okay, so it's just meaningless even if you use 50 or 20 layers. it's still going to be act like or similar to a single layer. Okay, so these two are normally not don't use in the backward propagation or deep learning.